I'm Kurbatov, and the topic of this report is Global Digital Identity System and Public Key Infrastructure. Today, the usual point is the independent verification of user data by each system individually. Very often, these methods are not very different from each other. Users transmit the same set of personal data, confirm registration using traditional methods, as a result of which they receive a local identifier that is valid only within the boundaries of the selected system. User must go through the same identification and registration process again and again, even if the identical dataset is provided. Moreover, at the same time, the data is not stored in a single unified format and isn't signed by the user when it's transmitted, which leads to the difficulty of finding the custodian of certain data and the inability to confirm data integrity and authenticity. Global services such as Google, Facebook, etc. allows users to sign in to other services through the OAuth protocol. But this protocol doesn't provide the required cryptographic reliability and use session mechanism to gain access to user data. What the global digital identity is? A global digital identity is a unique entity within an identity system that represents a specific subject and it associates with information identifying this object. There are several ways to timestamp data. In the first case, it is just a hash value of the dataset, but at the same time, the users won't be able to prove that he owns this returned particle without revealing the entire dataset. The second way is to use Merkle trees. In this case, you can prove that you own a certain attribute without relevating other ones. To do this, you need to use only two values, Merkle root and Merkle branch. Okay, let's take a look at the proposed account structure. Account or global identifier is an immutable and unique value within an identity system, represented as a byte string. This value is generated when the identity provider creates the new user's account. The main requirement is the uniqueness of this value within the system. Public key is a public key value with the private key of which all transactions initiated by a particular account are signed. Readable identifier list is a set of hash values from identifiers in other systems, such as email address, Facebook ID, etc. Also, each hash value is associated with a specific set of confirmations from other network members that they checked that the account owner owns the specified email, Facebook ID, etc., which correspond to the specified hash values. Okay, the next one, Merkle root for main data, is a root value from the user's main set of personal data. It's assumed that the values included in this set will not update it frequently, and therefore they will remain confirmed even if other account fields are changed. Okay, the next one is a main data confirmation list. It consists of a set of records consisting of the identifier of the provider and information about the set of main data they have verified. Okay, the next one, Merkle root for additional data. It's same to main data list, but it's a root value of additional set of user personal data. It's assumed that the values are included in this set will change and correspond to confirmations more often than the main set. Okay, the next one, additional data confirmation list, consists of a set of records consisting of the identity of the provider and information about the set of additional data they have verified. And the last one, it's recovery providers list and recovery power. It determines the set of identity providers and their amount needed to restore access to the account and change the public key. Okay, there are only two roles on the platform, identity provider and identity owner. The provider verifies the owner and adds appropriate proofs to the system. It's important that each member of the system can perform both roles. The global digital identity system provides that each participant who has an account can send a transaction to the network. Transactions are stored as an ordered set of blocks each of which contains a hash value of previous one, which provides the ability to control the integrity of the history of events associated with global identities. A transaction in turn consists of a set of defined operations. There are four main types of operations: the operation of creating an account, the operation of changing or adding data associated with specific global identity, confirmation operations of data associated with the identifier, the operations of restoring access to the account. Okay, it's an identity life cycle. The account creation operations can be initiated by any existing account. As a result of the operation, a new account is created in the identity system, and its identifier and public key are determined. Data change operations includes operations whose purpose is to change or add main or additional personal data of the user, as well as change the values of identifiers associated with external system. Such transactions can only be signed by account owner and verified using the public key value specified in the account. In fact, each user personally determines the data set what he wants to associate with the global identifier. Identity providers, in turn, have the right only to confirm the data set by the user. Okay, data verification operations include operations whose purpose is to confirm main and additional personal data. Such transaction can be sent by identity providers in relation to a particular account. Such transaction contains information about the identifier of the account to which the confirmation is carried out, about the value of marker root to which the data verified but it belongs, as well as about the set of data itself that has been verified. And the operation to restore access to the account can only be signed by the owners of the identifiers that were defined by the user at the time of creating or updating the account. In fact, the user personally determines the set of trusted parties and their required number, which can confirm his identity and send the transaction to update the public key of account. In fact, carrying out all types of operation described constitutes the life cycle of the account. Okay, an important feature of such system is the independent decision making regarding the identifier by the consumer of information. There is no information in the system that directly determines the validity of a particular identifier. There are only accounts and votes confirming the data of these accounts. Thus, the issues of trust is submitted entirely to a client side. In this case, he can personally determine the methodology which will be described when calculating the level of trust. One of the methods for determining trust is the number of identifier confirmations by other network participants. However, it should be borne in mind that this method is subject to a cyber attack. One of the accounts can create a large number of other accounts that confirms the identity of one of the participants in the system. The second approach is to trust only a specific provider or several providers. For example, being a client of the bank, I trust its identification mechanism and can set up my site in such a way as to trust only those accounts that been verified by the said bank. Also, this schema described is somewhat centralized. If the number of providers, then the user trust is small. It will be quite effective and expect most user due to its simplicity. In the third case, if the objectiveness of the result is really important for the network member, he can build complex verification algorithms that evaluate both the level of trust for providers who confirm a specific account and providers who confirm an account with a specific provider. It is important to note that whichever way the consumer use identification results, the system provides the ability to fully customize the verification algorithm, which lies solely on the client side. Okay, passing identification information between providers. In order to meet the GDPR policy, it's necessary that PII users are transferred and processed only with the permission of their owners. If personal data is transmitted directly by the user to provider, everything is quite simple. When establish a connection, the user gives the permission to process his personal data. However, difficulties arise if the register doesn't require data directly from the user, but from the party that has previously authenticated. For example, the user doesn't keep all the necessary data for registration on the service. However, this data was previously confirmed by register accordingly from him stored. Okay. Since the provider that stores PII users cannot distribute this data without first obtaining permission to do so. This permission must be provided by the user. Such permission must contain the date and time of its formation, the identifier of the PII owner's account, the set of data that is allowed to be transferred to the second party, as well as the identifier of the recipient site. Note that the request must be signed by a private key that is tied to the user's account. If the register receives a similar request from the user, he or she checks the signature value of the request using a public key that is specified in the user's account. If the signature is valid, then he looks at what set of personal data is requested, and if he really has the required set of personal data, then he sends them and the Merkle branch value to the requesting party. The requesting party carries out a procedure similar to the described earlier. It checks that the received data is in root hash value and then converts the personal data. The timestamp in the request is necessary to ensure the confidentiality of updated PII. If the user has updated his personal data set and doesn't want to party that previously received permission to access the old set to be able to receive updated data for same permission. Therefore, when checking permission, the register compares the time of sending the transaction with the updated data and the time for obtaining permission. If the time for obtaining permission is shorter, then access to personal data of user isn't provided. Okay, the implementing of identity system functional scheme described in this report doesn't apply mandatory abandonment of existing X509 infrastructure. Moreover, the simple integration of existing certificates is supposed by adding them to the account structure. The key idea of such a system consists partially in transferring control of data into the hands of their owners and unifying access to various services through the use of cryptographic methods. When user data is tied to a specific key, ownership of which proves the authenticity of the subject, only then can the system be sure of the authenticity of the requester. Okay, guys, thank you for attention. Goodbye.